Okay, so we've talked about sound intensity, which is that power per unit per square meter, or power per unit area. Now we also need to talk about sound intensity level because this is the more common unit that we use to measure the volume of sound, and this is what you're used to, like when we see things in decibels. So if the intensity of a sound is about 10 times that of another, if we're about 10 times louder than another sound, then a person really only perceives it to be about, well, about twice as loud. And because of this, we're going to use a logarithmic scale to measure a loudness, and this is going to be our sound intensity level. I use beta here. Actually, we're going to use L to describe the sound intensity level as the variable. And so this sound intensity level we're going to define as 10 times the log of I over I naught. And this is going to be measured in decibels. And this is abbreviated dB. Now later we're going to talk about how, or you might wonder why we have this factor of 10 here, and I'll show you why in just a second. But let me just go ahead and say the reason we have this factor of 10 here, and it just sort of seems like it's thrown in, this factor of 10, because that doesn't make it a true logarithmic scale. This factor of 10 comes in because really the unit for sound intensity level is the bell. And so we're instead measuring in decibels, and that's why we have that factor of 10. Deci is one of those metric prefixes. It means 10 to the minus 1, and that brings a factor of 10 in here. It's not terribly important, but if you're wondering, gosh, where does that factor of 10 come from? That's why, because sound intensity level, the unit is actually the bell, but we measure it in decibels. Don't see that metric prefix very often. Now here, I naught is that threshold for hearing. Remember, this is very much a human-centric measurement. It describes how we perceive this, how loud we perceive the sound to be. And so we have that threshold for hearing coming in the I over I naught. That's this value right here. Okay, so for example, we can compare the intensity of two sounds. But first, let me actually just review our logarithms and make sure that you understand what logarithms are. Let's say that we have n is equal to a to the x. So for example, if we let a be 10, which we will in this case because we're dealing with base 10 algorithms. If you're dealing in other algorithms like, natural logs, then you're using Euler's number as your base. Or you can have any base, but right now we're dealing in base 10. So 10 to the squared is equal to 100. Now, if we write this in terms of logarithms, we'd say log base a of n is equal to x. That is the log base 10. We're going to imply that we have a base 10. Log base 10 of 100 is equal to 2. So, for example, what is the log of, I don't know, 1,000? My gosh, what is a log of 1,000? Well, 1,000 is equal to 10 to the third, so the log of 1,000 is equal to 3. And log of 10,000 is equal to 4. 100,000 is equal to 5, and on and on. Okay, so with that being said, we can compare the intensity of two sounds. Remember, we started with this expression, L is equal to 10 log of I over I naught. And so if I divide both sides by 10 here, gets rid of that, and then I take 10 to the L over 10 is going to equal to I over I naught. And that's where I get this thing right here. Now, a change in 10 decibels, that is a change in delta L. So if I have a change in delta L of 10 decibels, that's going to be 10 to the 10 over 10. That's going to equal to 10 to the 1 or equal to 10. That means that a change in 10 decibels will give me an I1 over I2 equal to 10. So my intensity then will increase by a factor of 10. However, if I have, so therefore if I go from 20 to 30 decibels, it's going to be 10 times as intense. All right. If I go from 10 decibels to 20 decibels, this is going to be I1 over I2 will equal to 10. It's going to have 10 times the intensity, even though, and the intensity level is also increasing by a factor of 10. Right, so it's increasing additively, but the intensity is actually increasing multiplicatively by a factor of 10. Now, if I increase instead by 20 decibels, well, let's think about that. So if I have 20 decibels by which I'm increasing, then I have 10 to the 20 over 10. Well, that's equal to 100. So if I increase by 20 decibels, say 30 to 50, then that's going to give me a factor of 100. All right, so for example, two sounds have intensities that are in the ratio of 2 to 1. What is the difference in their decibel levels? Well, I want to start over here. So I have the intensities that are in a ratio of 2 to 1, and then this is going to be 10 to the delta L over 10. All right, I do the logarithm of both sides. Log of 2 over 1 is equal to the log of 10 over delta L over 10. This effectively gets rid of that. It's like doing it on both sides. What is the log of 2? Is 0.3. So this is 0.3 is equal to delta L over 10. So when I go up by a factor of 2, say my intensity goes from 20 watts per square meter up to 40 watts per square meter, right? That is that ratio of 2 to 1. Then I'm going to get a delta L equal to 0.3 times 10, or 3. That means, for example, I've gone from some decibel to some decibel plus 3. Okay? All right, so you have some homework problems. Make sure that you know how to deal with this, and then we'll also have some concept test questions on the OP quiz. All right, we'll come back to the Doppler effect.